Alright, let's do this. Well, it looks complicated. First of all, what does it even mean? Well, when it is like this, sine 2x dx plus cosine 3y dy, it kind of means that they have already done half of the work of separating the variables for us. So the initial differential equation was dy over dx equals minus sine 2x over cosine of 3y, but then they kind of multiplied by dx and multiplied by 3y and then moved everything to the left hand side. Well, however, of course, it is, well, if we just want to follow the method of separating variables and integrating, then we should probably rewrite it as cosine 3y dy equals minus sine 2x dx. So now the variables have been separated, so everything with y is on the left and everything with x is on the right. So then we do integration. So then the antiderivative of cosine 3y is 1/3 of sine 3y, and the antiderivative of minus sine 2x is 1/2 cosine 2x plus constant. Right? So then the next step is to find the constant. So notice that this is an initial value problem, and when we have an initial value problem for a separable differential equation, the next, so as long as we got this expression with the constant, we need to find the constant first and then we solve for y. Okay, this is important. And so the next step is to find the constant. So how do we find the constant? We use the initial condition. So in the initial condition, so 1/3 sine 3y in the initial condition is pi over 3, so we write 3 times pi over 3 equals 1/2 cosine of 2 times, and x in the initial condition is pi over 2, pi over 2 plus constant. Okay, then 3 over 3 cancels out, sine of pi is 0, so then 2 over 2 cancels out, cosine of pi is what is -1, and this whole thing becomes c minus 1/2 is 0, so the constant is 1/2. So it means that the equation that we've got is sine of 3y. I'm going to multiply by 3 right away, equals 3 over 2 times cosine 2x plus 3 times 1/2. Okay, or I can rewrite it as sine of 3y equals, well, let me take 3 over 2, factor it out, sorry, 3 over 2. 3 over 2 times cosine 2x plus 1. Strictly speaking, I could probably just go on from here, but I think it is nice to simplify it a little bit. So let us just rewrite it as 3 over 2. Then cosine of 2x, I hope you remember that this is cosine square x minus sine square x plus 1. And then notice that cosine square x plus sine square x is 1, so 1 minus sine square x is actually cosine square x. So then I get 3 over 2 times cosine square x plus another cosine square x. And then, well, basically it cancels out. So this whole thing is just 3 cosine square x. Alright, so we've got this equation that 3y equals, sine of 3y is 3 times cosine square x. Now, in other words, the equation is of this type. So sine of something, so let me just write like alpha. This alpha is going to be my 3y equals, well, some fixed number, say, I don't know, say beta, whatever. So the question is to find alpha. Well, if you forgot your junior college or polytechnic mathematics, or I don't know, maybe they teach it in the first year, so let me remind you how this is done, right? So sine of something is a given number. So this is the graph of the function y equals sine x, and then suppose that y equals, well, let's say that just for the sake of the example, 0.6. And so how do we find x? So x. So what is x? Well, so we know that sine of x is 0.6. So which means that x equals arc sine of, well, inverse sine of 0.6 is going to work. So which you can see by by the fact that this is at this point all the three lines and curves that they intersect. But what is this? And there is also this point, this point, this point, and so on, right? So there are infinitely many solutions. So how do we write the general solution? So recall that the function sine x is periodic with period 2 pi. So if arc sine of 0.6 is a solution, then plus 2 pi is also a solution. And arc sine inverse sine, say minus 2 pi is also a solution. And I don't know, maybe plus 4 pi is also a solution, and so on. So there's going to be infinitely many of them. But that's not all. So by accounting for this period of 2 pi, so we only get half of possible solutions, but we miss the other half. So this is the one. How do we know what this is? So, well, notice that one semi-period of sine, so the sine x, it kind of starts from 0, then goes up, and then goes back to 0, and this semi-period is pi. But these two points, so inverse sine of 0.6 and the other one, so they're kind of symmetric, so which means that if one of them is alpha, then the other one is pi minus alpha, right? So in other words, pi minus inverse sine 6 is also going to be a solution. So right, so notice that, let me just get rid of these. So notice that this and this, they are kind of symmetric about the line x equals pi over 2. But then of course, if this is a solution, when we add 2 pi, we again get a solution. We add 4 pi, we get another solution. We subtract 2 pi, sorry, we get yet another solution, and so on and so forth. Okay, I hope it's clear, right? So it means that basically it means that, generally speaking, it means that alpha equals inverse sine of beta plus 2 pi n, or pi minus inverse sine of beta plus 2 pi n are solutions. So in our case, 3y is the argument of sine. So 3y can be inverse sine of 3 cosine square x plus 2 pi n. This is kind of one series of solutions. Or 3y equals pi minus inverse sine of 3 cosine square x plus 2 pi n. That's another series of solutions, and in other case n is an arbitrary integer. So it has to be a whole number, could be positive or negative. Now which of the two is it, and what is n? How do we find? So we've got to use the initial condition again, right? So now let us try the first one. Okay, so 3 times in the initial condition, y equals pi over 3 times pi over 3 equals, what is it? Inverse sine of 3 cosine square x. So x is pi over 2, cosine of pi over 0, so it's just 0 plus 2 pi n. Well, but this is 0, So this is pi, and we get that pi equals 2 pi n. So now the left hand side is an odd number, well, an odd multiple of pi. This is odd multiple of pi, and this is an even multiple of pi, right? So which means that it's not the case, right? So this is kind of wrong. So this is wrong. So which means that we have to be in the other scenario. So when 3y equals pi minus inverse sine of 3 cosine square x plus 2 pi n. So let us figure it out. So 3 times y is pi over 3 times pi over 3 equals pi minus inverse sine of, well, 0 is the same calculation, plus 2 pi n. Now inverse sine of 0 is just 0. This is pi equals pi plus 2 pi n. So n equals 0, and it works. And so here n equals 0, and therefore 3y equals pi minus inverse sine of 3 cosine square x is the answer. Well, strictly speaking, we should solve for y. So y equals 1/3 times all this pi minus inverse sine of 3 cosine square x. And so this is actually the answer. This is the answer to this question. Is it all? Actually, well, almost, but not exactly, because there is a little issue here. Let me explain what the issue is. Let me maybe to demonstrate what the issue is. Let me just erase some of the stuff. What I want to say is that in differential equations, it is always very important not just to find the answer in a closed form, but also you need to figure out the domain of the answer, right? So what is the possible set of values of x for which the answer is well defined? And here we may have a problem. So the problem is that whenever we have inverse sine of anything, then whatever is the argument of inverse sine is, it has to be between -1 and 1, right? So it has to be less than 1, and it has to be bigger than -1. The reason is because when we are calculating the inverse sine, we are trying to find the angle whose sine is given, and sine is always between -1 and 1, right? So inverse sine of 3 cosine square x. So it means that 3 cosine square x has to be between -1 and 1. Now let me explain again. So go back to the graphing part. So we have 3. Okay, maybe. Yeah. So it means that cosine square x itself is actually less than 1/3. Yeah. Also notice that 3 cosine square x is more than 0. So in particular, it is more than 1. So this inequality is equivalent to this. So cosine square x is less than 1/3. Well, so cosine square x and here is the line y equals 1/3. 1/3. And so cosine square x has to be less than 1/3. So which means that well, the domain of our solution cannot be, say, this interval, because along this interval from -1.205 or whatever to 0. Whatever, cosine square x is bigger than 1/3, right? So and we need it to be less than 1/3. So also notice that the initial value of x is what it was, pi over 2, right? So pi over 2 is here, so which means that the domain of the solution is the interval on which cosine square x is less than 1/3, and it should contain pi over 2. So in other words, this is the domain of our solution is between 0.955 and this point, which is 2 point something something. So what are these points exactly? Well, and then if you just think a little bit about it, then you will realize that this is the point. Well, cosine square x, when cosine square x is exactly 1/3, it means that cosine x is 1 over square root 3. So we are looking for y that is equal to x inverse cosine of 1 over square root 3. Stop. Somehow it doesn't work. Yeah, okay, now it works. This is the point, and the other one is the one that is symmetric to it from well, about the pi over 2. So I guess it has to be is pi minus this? Yeah. Okay, so the it means that the correct answer is x given by the formula that we have just figured out, where x is in the belongs to the interval between these two numbers, inverse cosine of 1 over square root 3 and pi minus inverse cosine of 1 over square root 3. So let me just write it out. So it means that x itself has to be between is bigger than inverse cosine of 1 over square root 3 and pi minus inverse cosine of 1 over square root 3. Yeah. And this is kind of the second part of the answer. I'm sorry. So the full answer is the formula plus the interval in x where the formula is defined.